Let's continue the class. If they join, let's see. Adnan is coming. Adnan is joining in the class. Yes.
Assalamu alaikum.
Wa alaikum salam wa rahmatullahi wa barakatuh. So, Adnan, thank you for joining. And we did,
Welcome, sir.
yeah, we did in last class till here. We are expecting them.
একটু উপরে যান তো দেখি কি উপরে একটু উপর থেকে স্ক্রল করে নেমে যাই
Yeah, let's
আচ্ছা
see.
হ্যাঁ
We did all this, huh? Origin of radioactive decay. Then this notes also available in your Google Classroom. Okay. Ziva is coming.
আচ্ছা স্যার
Yes.
স্কুলে থাকলে যেরকম আপনি একদম সামারাইজ করে ফেলেন নোটস গুলো এই নোটস গুলো কি সামারাইজ নোটস নাকি আমাদের সামারাইজ করে নিতে হবে
Yeah, later on I will summarize, no problem. But here, look, we are covering all the things. If there is more details, then it's better for you to understand, right? You can read. I told you that this detection of radioactive emissions, we are doing Geiger-Müller tube, then photographic film, then cloud chamber. All this we do not need all these points or all this description. We don't need. We only need some of the things. The last class I told you that the cloud chamber. What is the purpose of it? You will know the name of the thing, that it is one of the detectors, right, of radioactivity. Then here is one thing in italic form. Those things you focus. I gave here italic form. Alpha particles are best for this. These things you will focus. Okay, this one, low energy particles only leave short trails. So just remember this. And here also you have the name photographic film, and it's used especially in nuclear power stations. They who are working in the nuclear power stations, that how much radioactivity is exposed to their body. That one in monthly rate they are getting the reading idea. Okay, that way they can take preventive measures. So this all I gave details to have a understand, like you in the class what we did, we were explaining many things, but we used to write little things, right? We discussed many things, but
Yes sir ওইটাতে সুবিধা হইতো
we wrote very little. But here, when I'm giving you notes, I have to give a bigger one, because some of the students, they are missing class. If I only give you short notes, they might require, or they might expect more explanation on those. However, you have one benefits here, that is we have the recordings. If you want to revise it more and more, and to get the important things, when I am discussing all these things, that time I am also discussing that which part is most important. That one you can focus. Okay, just now I told that this one, the italic form, you you give more emphasis. Okay, clear now?
Yes.
Adnan, now Ziba, thank you for joining. It's very hard to come in class, right, Ziba, in the early morning?
Yes.
Yeah. When did you go to bed last night?
After 2 a.m.
Oh, then
Sir.
got up now? Or you...
I got up at 6:52 once, then at 8, then at 8:30 finally.
So it's not a continuous sleep. That's another problem. It's not a sound sleep. Again and again you are breaking your sleep, uh, with the scarcity that you are missing the class or not. This way it's happening. Okay, let's
So,
continue with this one. Modern detectors. We have discussions on two modern detectors. We will just go through. Adnan, could you please read it? Modern detectors. Your vocal is very good. MashaAllah. Read.
Jazakallah. Modern detectors, modern কি মশাই বললি আবার বল
Yeah,
sorry,
you
sorry.
you continue.
আমি কি
Continue.
বলছি?
Modern detectors. Modern instruments are much more sensitive than the other listed above. Scintillation detectors work by the radiation striking a suitable material, such as sodium iodide, and producing a tiny flash of light. This is amplified by a photomultiplier tube, which results in a burst of electrons large enough to be detected. Scintillation detectors form the basis of the handheld instruments used to monitor contamination in nuclear power stations. They can recognize the difference between A, B, and Y radiation, alpha, beta, and gamma radiation, and make different noises such as bleeps or clicks accordingly.
Okay, so
Solid state
yeah,
detectors.
wait. So we are little bit highlighting on this scintillation detectors. These are actually like we are having some metal detectors, right? Like hand-led metal detectors. Can you remember in our school also sometimes, uh, or in some places which are VIP people are going. There we are using metal detectors. The guards are using metal detectors, right? Hand-lit. So this scintillation detectors is also one kind of hand-lit instruments, which is detecting alpha, beta, gamma radiations in power stations. And for alpha, beta, gamma, they are giving different kinds of sounds. Okay, so it's a bit more updated and upgraded detectors. Clear?
Assalamualaikum, sir.
Walaikum salam. Aisha, thank you for joining. Thank you so
Sir,
much.
এটা কি পড়াচ্ছিলেন?
This
আমি তো
one,
দেরি
just
করে এসেছি।
we just started this one, and we had review on the previous classes. Okay, and we
Okay,
were
okay.
waiting for you. Okay, then
Okay, sorry,
continue.
I'm
This,
late.
yeah, it's okay. Then continue, Adnan.
Solid-state detectors are the most up-to-date instruments. They are used in particle accelerator laboratories to show the results of high-energy collisions, with banks of them clustered around the collision site, feeding data into huge computers. The way they work is way beyond what we need for IGCSE O-levels, but basically they are similar to the CCD, charge-coupled device, silicon chips used in video cameras.
Okay.
Characteristics of three
Yeah,
types of emission.
wait. Solid state detectors. This one is the most upgraded instrument for detecting radioactivity. And here we are using also computers to get, the data collection and showing the data. So this one we don't need. I already mentioned it. The way they work is way beyond what we need for IGCSE or O levels. But basically, they are similar to the CCD, charged coupled device. CCD is silicon chips. This one also may be beyond your knowledge. What is charged coupled device? So we do not need it actually. Just remember the name. That's it. We'll get more details in honors level. This one. Silicon chips used in video cameras. Yeah, in our third year, we had solid state physics, and also in our masters we had solid state physics. There we got some more, explanation of all these solid state terminologies. So now just you know the name. That's it. You can recall that yes, at least we got this name in our O levels. Now the three things already we discussed many times: alpha, beta, gamma, and we had some of the ideas of them. What is alpha? What is beta? What is gamma? So those things we are
আবার
going
একটু
to.
বলেন তো, আমি ফার্স্ট ক্লাসে অ্যাবসেন্ট ছিলাম।
Yeah, I am just having the review. Then we will start. No problem. Alpha particles, as we discussed before, that alpha has two protons and two neutrons. That's why they are positively charged. Neutron, we know it is neutral, and protons, they are positively charged, and that's why alpha particles are positively charged. Beta particles, they are simply the electrons. Now beta emissions, when we are getting, we are either getting negative electron or positive electron. Positive electrons are called positrons. Yeah, they are also one kind of emissions in the radioactive, from the radioactive particle, and they are also the particles available. Sometimes we are having these particles inside the nucleus. So here we have uh, beta particles are electrons emitted with varying speeds, which can be as high as 9/10 of the speed of light. And gamma rays, these are not particles. Gamma rays are unlike alpha and beta. Alpha, beta, we are saying particles, but gamma, we are saying gamma rays or gamma radiations. Gamma rays are electromagnetic waves of very short wavelength. They are often emitted at the same time as alpha or beta particles. Gamma rays are massless. So that properties of light, that one is followed by gamma rays, and from the electromagnetic spectrum we are done with that. There we got all the rays, right, from the gamma rays to radio waves. And we know that gamma rays, they have the shortest wavelength, and in opposite we can say they have the maximum frequency, right? Can you remember this from the electromagnetic
Yes, sir.
spectrum? Gamma rays, they have the most frequency, and they are massless. Gamma rays, they don't have any charge, they don't have any mass. This one we have to remember here. And alpha particles, again, we are saying they have two protons, two neutrons. That's why it is equivalent to helium nucleus. In helium, we have extra electron. As atom, we have in helium electrons, but the nucleus of helium contains two protons and two neutrons. So that's why we are saying alpha particles, we are considering as helium nucleus. It has a mass of 4U. That means 4U means 4 atomic mass units. We know that one. 4 multiplied the mass of proton, and the charge is +2 electron. That means the electron has the charge, the same charge we have for proton, but it is positive. Alpha particles travel up to about 1/10 of the speed of light. That means the light of speed of light. What is the speed of light? Can you recall that one? Anyone, please?
10 to the power 8.
Yeah, we said 3 into
3
10 to
into
the
10 to
power
the
8
power 8.
meter per second. 3 into 10 to the
Yes.
power 8 meter per second. We get that one. So it's 1/10. 1/10 of the speed of light. And beta particles, they are 9/10 of the speed of light, as they are lighter, right? Beta particles are very light elements, right? They are light particles, so they have more speed, right? 9/10 of the speed of light. Like electrons, they carry negative charge of -e. Beta particles are much lighter than alpha particles. So these are common, or the basic things about alpha, beta, gamma. Now we will go for more characteristics, more properties of alpha, beta, gamma. Now we are having more details. ionization effect. Can Moshi read it? Ionization.
স্যার আমারে ছাইড়া দেন, আমি এমনি ঘুমের অবস্থায় আছি।
Please read. Please read. Please read loudly as much as
স্যার
possible.
স্যার স্যার আজকের জন্য স্যার প্লিজ স্যার, আমি
Okay,
এমনি স্যার আমার অবস্থা
Ziba.
খারাপ স্যার।
Ziba, you continue. No problem. Ziba, could you please read ionization? Hello, Ziba.
Yes, sir. Can you hear me?
Yes, yes, now it's okay. Read, please.
Ionization. Ion is a charged atom formed by losing or gaining electrons. All three kinds of emissions are capable of creating ions. Alpha particles knock electrons out of nearby atoms, thus ionizing the atoms. The alpha particles are much heavier than the electrons and can simply dislodge them from the atoms. Thus, they have the most powerful ionization ability. Beta particles are less strongly ionizing than alpha particles but more than gamma rays. It is less likely for a lighter beta particle to dislodge an electron. Gamma rays are the least ionizing of the nuclear radiation as it is unchanged.
Uncharged.
Uncharged.
So here the ionization is related to charge. The one which have more charge, that one has more ionization capacity. This is the basic. Is it clear to all of you? Aisha? Ionization is related to the charge available in the particles or the gamma rays.
Negative or positive?
Yeah, so alpha particles, they have the most charge, right? And they are the most heavier. So they can simply dislodge them from the atoms. Like, the idea of momentum is not available in your O levels. You will get in A levels. And that is, if like one bigger object is coming with some speed and it's hitting a small object, right? Then what will happen to the small object? That will move with more speed, right? It can easily, displace the smaller object, isn't it? Hello?
ইয়েস
Hello? Yes, you understood it. So alpha particles, they have a greater charge and they are heavier. That's why they can easily displace or dislodge the electrons from the outermost shell. And you know that if electrons are coming out from any atoms, then the atoms become uh, an ion, right? So this is called ionization. Since alpha has more positive charges, they have more charges and they are heavier, so they have more ionization capacity. Then beta particles are less strongly ionizing than alpha particles, but more than gamma rays, it is less likely for a lighter beta particles to dislodge an electron. That means beta particles also have ionization power, but not like alpha particles. Because they have only one charge. Uh, Electron has only one charge. And that's why they are also lighter. That's why they can ionize, but not like alpha, less than alpha. And gamma rays are least ionizing. Gamma rays, they don't have any charge. However, they can also ionize because of their speed and their frequency. Okay, they are traveling with the speed of light. Because of this speed, when they are hitting the electrons with that speed, that kinetic energy, they can also dislodge some electrons, right? So they have also ionizing effect, but it's very less as they don't have any charge. So this part is clear to you, all of you, ionization?
Yes, sir.
Is it clear, everyone?
Yes, sir.
So can you sum up then about alpha, beta, gamma, their ionization? Aisha, can you tell us what you understood from the discussion?
So
Hello.
I can't really see properly. Can
Now,
you see properly?
now,
No,
now
like
is it
there's no problem. No, there's no problem with the screen. There's a problem with my eye.
okay? Okay.
I haven't
Still,
slept last night,
still,
so
it's
it's
not
a
clear
problem.
to you. Whatever you got from our discussion, that one you can just repeat about alpha, beta, gamma ionization.
Okay, so when alpha particles ionize, they pick up the electrons
Mm-hmm,
out of the atom.
mm-hmm,
That's one thing.
mm-hmm,
And during gamma radiation, the gamma
mm-hmm,
rays also dislodge the electrons from the atom.
mm-hmm. What about beta?
I don't understand that.
Beta particles, they have also charge, right?
Yes, sir.
So they can also dislodge the electron as they have charge, they have some mass, they can hit the electron and take out some electrons also, right? Uh, uh,
Yes.
so they have also some capacity to dislodge electrons to ionize the atoms, but their power is less than alpha. Okay. So out of alpha, beta, and gamma, which one has the most ionization capacity?
Gamma rays.
Alpha.
Which one? Which one has the
Alpha rays.
most
Alpha.
alpha? Alpha has the most ionizing capacity because they are more charged, right?
More
And
charged, yeah.
yeah, and beta they are medium, right? Less than alpha,
But
uh,
more than gamma.
more than gamma. And gamma has the least ionizing capacity. That's the
Ionizing capability.
yeah, that one only you have to remember. Then which one has most ionizing power? Alpha. Then less than alpha, that is beta, and least gamma. Is it clear?
Yes, sir.
Yes,
Is it
sir.
clear, Aisha? So just remember
Yes,
that.
sir.
Remember that, and here we have all the discussions why alpha has more, why beta has less, and why gamma has least. Here they mentioned that why gamma has least because it is uncharged.
Okay.
Sometimes you will get MCQs that why gamma has least ionizing power. That's the reason it's uncharged. Okay, now penetrating power. Penetrating power. Can you read Ziva? Penetrating power.
Yes, sir. Penetrating power. Alpha particles are the least penetrating of the nuclear radiations and can be stopped by a sheet of paper. They can only pass through a few centimeters of air. Beta particles are more penetrating and are stopped by a thin 1 millimeter sheet of aluminium. The fastest beta particles have a range of meter or so in air. Gamma rays are the most penetrating nuclear radiation. Intensity of gamma radiation can be reduced to half by 1 or 2 centimeter thick layer.
Okay, so can you tell me please on which thing this penetrating power is depending?
The paper is stopping it.
We wavelength or
Mm-hmm.
probably. I'm Janila.
Mm-hmm. Yeah, very good. You are giving the your opinions. That's really
And the
good.
shorter the wavelength, the more the penetrative power আর
Yeah.
frequency কি matter করে যদি
Yes,
matter করে
yes,
তাহলে
yes,
ওইটাও
yes, yes. Listen, if you compare with the all the electromagnetic radiations from the gamma rays to radio waves, Then the one which has the shortest wavelength, that one has most frequency, and frequency relates to intensity. If the frequency is more, then the intensity is more. So the one has more intensity, that one has more penetrating power. Okay, clear? This is one idea among the all electromagnetic waves. Uh, Here we have another thing, that is uh, in our previous discussion we got that one. Here at the beginning we got there is speed, right? Uh, Alpha particles travel up to about 1/10 of the speed of light. Then beta particles 9/10 of the speed of light. Gamma rays, they have speed of light. So which one has most speed?
Gamma ray.
Yeah, gamma rays, they have the most speed. That's why they have most penetrating power. And beta rays, they have less than gamma. That's why they have less penetrating power than gamma, but more than alpha. And alpha has the least penetrating power. So, what is the origin, or what is the reason for penetrating power here mostly? Can you tell me? What is the
Wavelength.
It's the main reason, that the speed of
Oh,
the alpha, beta, and gamma. Which one has most speed? That one has most penetrating power. Is it clear?
Sir.
Is it clear to you?
yes, sir.
Yeah.
Yes,
Yes,
sir.
sir.
So beta, it has less penetrating power because it has less speed, 9/10 of speed of gamma. Speed of gamma is how much? Can you tell me speed of gamma?
1/10 the speed of light.
No, no.
Beta
Speed,
alpha.
yeah. Speed of gamma is the same as light, 3 into 10 to the power 8. Alpha is 1/10. Look here, we said. Alpha travels up to 1/10. So alpha has 1/10 of the speed of light. Is it clear now, Adnan? Hello, Adnan?
Yes, sir.
Yeah. So beta has 9/10 of the speed of light, and gamma has the same speed as light. So can you now sum up this one? Penetrating power. Why alpha has least, why beta has more, and why gamma has most. Adnan, can you summarize this?
The penetrating power depends mostly upon the speed, so that is why gamma rays have the most penetrating nuclear radiation since their speed is the greatest.
Yes, and beta.
And secondly is beta, and lastly is alpha.
Alpha has the least penetrating power, right?
Least penetrating power, yes,
Because it has the
since the
least
lowest
speed.
speed.
Yeah, lowest speed. Very good. So can we go to next one, next part? After penetrating power, we have the ideas at a glance, the one you asked for. Adnan, you wanted the notes this way, right? At a glance. Adnan,
Yes, sir.
so this one is giving you the idea at a glance notes, that the properties or the characteristics of alpha, beta, and gamma you are getting in a small space. Okay, so can you read this part? What about alpha, beta, and gamma? Range in air is given, ionizing power. So can you continue this reading?
The radiation of alpha range in air is 5 centimeter, Ionizing power is it is highly ionizing. Alpha cannot pass through paper. Alpha cannot pass through 5 millimeter of aluminum. Alpha cannot pass through 5 centimeter of lead. The range of beta in air is 15 centimeter, and the power of ionizing is medium. Beta can pass through paper, but it cannot pass through 5 millimeter of aluminum, nor can it pass through 5 centimeter of lead. The range of gamma in air is much farther, and the ionizing power is weak. Gamma can pass through paper and 5 millimeter of aluminum, uh, but while passing through 5 centimeter of lead, almost all of it is stopped, but some get through.
So you should memorize it. Okay, this one is given in short, everything is there. So here you got no, no, no. That means alpha has least penetrating power, right? It cannot even pass through paper. Okay, so it has least penetrating power. Then beta, it can pass through the paper, but it cannot pass through aluminum. Then gamma, it can pass through the paper, it can pass through the aluminum, and also almost all of it is stopped, but some gets through. That means lead, only 5 centimeter lead can stop gamma, otherwise it will go. It has most penetrating power. So is it clear, all of you?
Yes, sir.
Hmm? Done. Then we have,
Don't even wait.
yeah,
Let me just
anything else, anyone, please?
let me finish writing it a bit.
This one is clear to you. Can we go to next part, or we will pass some more time here? Hello? Should I explain it again? This
No,
one.
sir.
Okay.
I got
Okay,
just
you
right.
got it. Thank you. Thank you. Now, deflection of all radioactive particles. How they are behaving in electric field. It also depends on their charge. Hmm. You know that electric field, we have positive and negative terminal, right? We have in electric field positive and negative terminal. Can you remember that one? In one cell or battery, we have positive and negative. Hmm? All of you? Hello?
Yes, sir.
So we have here one electric field. That means there is one plate, metal plate with positively charged, and other metal plate is negatively charged. And in electric field, we showed you in static electricity, when we discussed static electricity, you got it that there is electric field lines going from positive to negative, right? This way, straight, positive to negative electric field lines. Can you remember that one? Electric field lines are moving from positive to negative. So these lines, the parallel lines are here available from positive to negative. Those are electric field lines, which is showing us uh, uh, it is an electric field. Now we know that alpha particles, they are positively charged, right?
Yes.
Isn't it? And as they are positively charged, when they are going closer to the positive terminal, they will be repelled, right? And someone is giving you one alpha particle here, and then they are asking you to show the path of alpha particles movement. Then you will draw a line like this. Okay, can you do it in
Yes.
structured questions? Or in MCQ, they will ask you that this type of deflection is correct or not. Okay, they will give you different directions. Sometimes they will give you bending this way, or straight. That time you have to identify which one is correct. Now beta particles, they are negatively charged, right? Aisha, beta particles are electrons, right?
Yes, sir.
So electrons are negatively charged. That's why when you are giving a beta source, that one will be attracted by positive and repelled by negative, isn't it?
Yes, sir.
And there might be some beta particles with more speed and some beta particles with less speed. Which one has less speed? That one we are saying slow beta particles with lower energy. That one will bend more. And the one with more speed, faster, higher energy, that one will bend less because of this speed or the kinetic energy. It will go through this place faster. That's why it will bend a little bit less. Is it clear? Hello?
Yes, sir.
Okay. So there is another thing we have to compare with the curve of alpha particles and beta particles. We know one thing, that alpha particles are heavier, right? And beta particles are lighter. So if you see that alpha particles, the way its curve is going, uh, the beta particles curve is going a little bit more curve. Did you notice it? Did you observe it? Why it is? Because alpha particles are more heavier. To pull or push any heavier things, it's tough, right? Isn't it? So for that reason, the alpha particles, the curve is not that much, as the alpha particles are more heavier. So if in your exam they are asking you to draw the path of alpha particles and beta particles, you have to maintain this. You will show less curve for alpha particles and you will show more curve for beta particles. Is it
Sir, what
clear?
about gamma rays?
Gamma rays, we did not go yet. We are going there. Okay. So alpha and beta, you are clear about this. You understood it. All of you understood about alpha and beta.
Yes,
Hello.
sir.
And gamma, you see, gamma source is going straight. It's not uh, affected by the electric field. That's why it is undeflected. We got here one thing. Uh, can you remember this? That gamma rays are uncharged, right?
Yes, sir.
So if it is uncharged, then why it will be attracted or repelled? It will not, right? That's why it is going undeflected. It's going straight. So is it clear to you?
Yes, sir.
So when they will ask you to draw gamma direction or the gamma's movement inside an electric field, that time you will draw a straight line like this. So all are clear, right? Now I am coming from there. Now without seeing, you will tell me. You will sum up about alpha, beta, and gamma.
Sir,
Uh, deflection
sir,
deflection of alpha, beta, and gamma in electric field. Uh, we will do. Ziba, can you sum up
sir,
how?
sir, sir,
Yes.
এক মিনিট শেষ হয়ে যাবে স্যার
স্যার
আরেকজন
এখনই মিটিং শেষ হয়ে যাবে না?
Okay. Should we continue it next class
Yes,
Yes,
after
sir.
sir.
5 minutes? Okay. Thank you.
After
After
5
5
minutes.
minutes, you join.
Sir, same link.
Yes. Same password and ID.